Assalamualaikum and hello everyone. Welcome to the video for Chapter 4 Introduction to Organic Chemistry for 4.3 Classification of Organic Compounds. In this video, we're going to learn to describe functional group, name the functional group, and determine the functional groups present in organic compounds. So what is functional group? Functional group is an atom or group of atom in an organic molecule which characterize the molecule and enable it to react in specific ways which determine its chemical properties. Okay, so that is the definition of functional group. So let us look further into what is the functional group present in organic compound. So first thing first, we're going to look for is the name of the class or the homologous series is alkane. Okay, and the general formula is CnH2n plus 2. Okay, but then for the case of alkane, there is no functional group. So that's why here it mentioned about ester. But for the example of alkane is CH3CH3. For example, if you draw alkane, again, we have maximum number of hydrogen. So C2H6 or CH3CH3. Okay, so that's the first one. The second one is alkene with the general formula CnH2n. Okay, so the structure of alkene, there must be the double bond. It must have a double bond. Okay, but then the name of the functional group is not alkene. That is the name of the class. The name for the functional group of alkene is carbon-carbon double bond. So this is an example for the carbon-carbon double bond functional group. Okay, the third one is alkyne. Alkyne is CnH2n minus 2 for the general formula. So what is the difference between alkene and alkyne? Alkyne is the one with the triple bond. Okay, so hence the name of the functional group is carbon-carbon triple bond. And then for the structure, it will be like this, where the structural formula, you can see there's the triple bond. So for the fourth one, the class or the homologous series is aromatic or arine. The general formula is CnH2n minus 6. Okay, the structure is like this one, okay, where it's actually an hexagon with a double bond, single bond, double bond, single bond, double bond, single bond. Alternating double and single bond ataupun selang-seli double bond, single bond, double bond, single bond, double bond, single bond. Okay, so for example, if I have this type of hexagon, okay, but then only one double bond, so that is alkene. But this case, we have 3, which it is alternating ataupun selang-seli, hence it is aromatic arine for the class or homologous series. Okay, it also can be drawn as this one, with a hexagon with a circle, because it shows that actually we have alternating double and single bond. But this one, we're going to look further into the next chapter, or chapter 7, benzene. Okay, so this is actually the structure of the skeletal structure. From this, actually, we can draw the expanded. So how do we draw the expanded? Again, for the skeletal, it does not show any carbon and hydrogen. So what does it mean? Any of the line here, it means that we have our carbon. So I'm just going to draw the expanded structure for benzene. We have carbon, 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 carbon. Okay, and then we're going to connect all of this carbon with a single bond first. Okay, but then we can see that for each of this one, we have double bond here. We're going to start, okay, double bond here, double bond here, double bond here. But this is not a complete expanded structure. We have to show the hydrogen as well. Remember that carbon must have 4 bonds. It could be double bond, it could be triple bond, it could be single bond, but make sure that each carbon must have 4 bonds. So when we come from this structure, we can see that each carbon only has 3 bonds. So what does it mean? It means that for the structure in the expanded form is that for each of the carbon, we have 1 hydrogen. Okay, so this is C6H6. Okay, so this is the structure. And the name of the class or homologous series is aromatic or arine. But the functional group, the name is benzene ring. Okay, and then this is the example of benzene ring present. Okay, the next or the fifth one that we're going to look at, the class or homologous series is haloalkane. So haloalkane is actually based from the alkane, but the difference is that we're gonna substitute one of the hydrogen with halo. Halo means that our halogen. Okay, so that's why instead of CnH2n plus 2, it's CnH2n plus 1. Why plus 1? Because one of the atom is substituted with halogen. So what is X? So I'm just going to label here. X or the halogen could be fluorine, chlorine, bromine, or iodine. It could be any of these for halogen. Okay. So that is the example of X. Okay, but then due to the presence of halogen in the structure, we cannot call it as alkene anymore. We're going to call it, for the functional group, it is halogen. But for the class or homologous series, it is haloalkane. So for the example here is CH3Cl, it could be CH3CH2Br. Also, where one of the hydrogen in the alkane is being substituted with the halogen. Okay. Okay, the last one, the last class or homologous series on your notes on page 6 is alcohol. So alcohol follows the general formula for CnH2n plus O. So how do we know there's the presence of alcohol? Where we have OH at the carbon attached. Okay, but for the class, the name is alcohol, where we have learned during our secondary school. But then because for this syllabus or for this specific learning outcome, we're going to learn about the name of the functional group. So the name of the functional group for alcohol is hydroxyl. Okay, so how do we know that we have hydroxyl present? Where we have OH. Okay, so that's the functional group on page 6. Now let's look for the class and the functional group for page 7. So first we have ether. So ether follows the general formula CnH2n plus O. But for the case of ether, the oxygen must be in the middle between carbon and carbon. Okay, so that is the name of the class, but the name of the functional group is alkoxy. So this is the example where the oxygen is in between the carbon itself. So for example, the second one here, if you draw in terms of expanded, we have CH3, and then we have oxygen, and then we have CH2, CH3. Okay. So we can see COC means that the functional group present is alkoxy. The next one, the class or the homologous series is aldehyde, where it follows general formula CnH2nO. Okay, so how do I know that we do have aldehyde for the homologous series or the class? Is that the C contain double bond O and the same carbon must have hydrogen attached to it. So what does it mean by R? R could be any carbon. It could be CH3, CH2, CH3, any of the carbon itself lah. Okay. So for the name of the functional group, it is carbonyl. Okay, so for the case of aldehyde, usually when we write down in terms of condense, at the end it must be written as CHO. For the case of alcohol, I'm just going to add in here. For the case of alcohol, usually if I have methanol, the CH3OH. Or for the case of ethanol, CH3, CH2OH. This is for the case of functional group of hydroxy. Okay, but then for the case of functional group of carbonyl, it is CHO. For the hydroxy or the class homologous series is alcohol. It must be at the end by OH. But for the case of aldehyde or functional group carbonyl, it must have CHO. The next class or homologous series that we're going to see is ketone, where the general formula is still CnH2nO. It's the same as aldehyde, but then the difference is that it contains C double bond O, but the C double bond O must be attached to carbon and carbon. Where for the case of aldehyde, one of it must be hydrogen. For the case of ketone, both of the attached ataupun bodyguard to the carbon C double bond O must be carbon itself lah. Okay, the functional group is still carbonyl. Okay, it has the same functional group because it contains C double bond O here. Okay, and then we can see that for the example, we have CH3, CO, CH3. So it means that C here, CO is C double bond O. Okay, so that is for ketone. For carboxylic acid, it is CnH2nO2 because we have two of the oxygen. Okay, so for the carboxylic acid, we have C double bond O, and on the same carbon, it must be attached to OH. Okay, and the name of the functional group is carboxyl. Okay, and then this is the example of carboxylic acid. The next one is ester. Ester still follows the same general formula, which is CnH2nO2, but then the difference is that we have C double bond O. C double bond O still attached to oxygen, but this oxygen, instead of attaching to H, it must be attached to any of the carbon. Okay, so that is the difference. Again, R means that any carbon. It could be CH3, it could be CH2, CH3, it could be CH2, CH2, CH3, any of the carbon itself lah. Okay, for the name of the functional group, it is not ester, it is carboalkoxy. In this case, when you look on the condensed structure, instead of the COOH at the end for the carboxylic acid, at the end here, it must finish up with the carbon and the hydrogen. The next class that we're going to look at is anhydride. Anhydride follows CnH2n plus 1, COO. So, how do we know that we do have anhydride present? Okay, it as if the same COC as in our alkoxy, functional group of alkoxy. Okay, but then it has the extra double bond O, where for each of the carbon has C double bond O. So this is the class, and the functional group has the same name, anhydride. Okay, so when we look based on the condensed CH3, COO, CO, CH3. Okay, CO means here C double bond O. Here CO, C double bond O. Okay, so that is for anhydride. Next is for acyl chloride. Acyl chloride, CnH2n plus 1, COCl. Okay, so for the case of acyl chloride, okay, it has C double bond O, but instead of attaching to OH, OR or OCOR, it is attached to chlorine, hence the name chloride. So C double bond O is attached to Cl. Okay, and the name of the functional group is the same as the class, which is acyl chloride. So we can see at the end here, we have COCl, COCl. So that is for the case of acyl chloride. Okay, next we're going to look for the class is amide, where the general formula is CnH2n plus 1, CO and H2. Again, when you see CO, it means that we have C double bond O. So it's the same here, C double bond O. But this case, NH2, C double bond O is attached to N. This one, the N can be attached to hydrogen. It could also attach to any of the carbon. Okay, so for the case of amine, the name of the functional group is carboxamide. Okay, so this case, again, we have C double bond O, but we have an extra where C double bond O is attaching to N. The next one that we're going to look at is amine. Amine follows the general formula CnH2n plus 1 NH2. So for the case of amine, where you see there's N, your nitrogen. So if you see any of the nitrogen present, so the class is amine, but the functional group is amino. So what is the difference between amino and carboxamide? Carboxamide must be attaching to C double bond O. But for the case of amino, the N is attached to any of the carbon, or it could be attached to any of the hydrogen. Okay, so the difference again, carboxamide must have C double bond O. So N is attached to C double bond O. Amino, only the presence of N. So this is the example of amine. Okay, the last class or homologous series is nitrile, where it follows the general formula CnH2n plus 1 Cn. Okay, so nitrile Cn is actually C triple bond N. Again, this is due to carbon will form 4 bond and nitrogen form 3 bond. We can see from the amine and the amino and carboxamide itself, the nitrogen prefer again to form 3 bond. And actually, even though from here we do not see that it achieve octet, actually for each of the end there's the presence of the lone pair. So the end again we prefer to form 3 bond is because it has one lone pair, and then when we calculate the formal charge will be 0. So that is the most possible for the nitrogen. Okay, so that is the name of the nitrile, is the name of the class, and the functional group is cyano. So the example here, we can see that C, here is C triple bond N, or sometimes the triple bond is not drawn, but at least you can see that we have CN, so it means that the functional group cyano is present. So that is all the functional groups and the class or homologous series that you should know. But usually the question did ask for the functional group. So please keep in mind the class and the functional group is two different things. We can see here the class, the carboxylic acid, the one that you have learned during your secondary school. The carboxylic acid is the class or homologous series, but the functional group is carboxyl. Okay, so next we're going to look for the examples itself. Example 1, page 8. Name the functional group present in the following compound and classify the compound according to their homologous series. Okay, so first we're going to look for is example A. So for example A here, okay, so let us see. So what is the functional group present? So we can see there is a carbon-carbon double bond here. Again, we can see that there's double bond. Okay, again, if you're not sure, so the question asks for the functional group and classify the compound according to their homologous series. So I'm just going to write down. Okay, so again, we can see that we have double bond here. So if you're not sure, let's us look based on page 6 and 7. Okay, so we can see from the page 6 here, we have the carbon-carbon double bond. Okay, again, the functional group here is carbon-carbon double bond, but the name of the class or the homologous series is alkene. So functional group is carbon-carbon double bond. And then the homologous series or the class is alkene. Again, since the functional group is this one, you have to write down the full name lah. C double bond is not accepted. You have to write down the full one. C, what does it mean by C? Carbon-carbon double bond. Okay, let us look for example B. So example B we have here. So the difference is that here we have NH2. So let us write down the functional group and the homologous series. Okay, so let us check based on our notes. Okay, so based on page 7 itself, again, the functional group present is NH2. So based on here, we can see there are 3 examples where we have N. We have the functional group carboxamide, N, amino, and cyano, N. But then at the end there, we can see that we do not have any triple bond, so cyano is not accepted. So it's either carboxamide or amino for the functional group. But then at the end, we only have NH2. We don't have any C double bond O. Hence, the functional group is amino and the class or homologous series is amine. So that is for example B. So for example C and D, you may try yourself again. You have to write down for both since the question asks for the functional group and classify according to the homologous series. Example 2, circle and name all the functional groups present in the following compound below. So let us look for example A. So again, since the question asks to circle and name the functional group only, so first let us check what is the functional group present, or we're going to circle the functional group present. So here, for this question A, again, this is a skeletal structure. Skeletal structure does not show any of the carbon lah. Actually, here we have carbon, 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 and each carbon must have 4 bonds. You can see that oxygen only has 2 bonds. Okay, so from here, what is the functional group present? We can see that we have oxygen here. Okay, usually for the carbon itself, we don't have any functional group. For the case of alkane, there's no functional group. So the tips is actually you're going to find out or determine it from the other atoms present. So here we have C double bond O. and then we have oxygen attached. Okay, so C double bond O attached to the oxygen. Okay, so let us look. So on page 7, we can see we have three example of C double bond OO. We have C double bond OOH, C double bond OOR, or C double bond O, C double bond O, double bond O. This one. Okay, so we have three of these examples. So again, let us check again. What do we have on example A? Example A, we have C double bond O, and this one is attaching to another carbon. So if you're not sure, then we're just going to label this one C and C. So we have COOC. Okay, so the oxygen is attached to another carbon. So the carboxylic acid or the carboxyl functional group is COOH is not accepted. So COOR is carboalkoxy. Again, R means that any of the carbon. So this is our functional group. So when we draw it or when we circle it, we're going to circle C double bond O and the carbon itself. Okay, it cannot be anhydride because if the O must be attached to another C double bond O. Okay, so let us circle for the example A. Okay, so for the circle, we're not only going to circle C double bond O, we're going to circle C double bond O and C as well. So this one. Okay, so what's the name of the functional group? Again, the class is ester, but the functional group is carboalkoxy. Okay, so that is example A. Okay, now let's look for example B. Example B, okay, so again, how do we know what is the functional group present? You check besides the carbon itself. So we can see here we have the first one is OH. So OH, okay, this is the question asked for functional group. This is alcohol. Alcohol is the name of the class. Okay, but then when we check based on our notes, alcohol is the name of the class or homologous series, but the functional group is hydroxyl. So we're going to name it again hydroxyl. But for this case, we not only have OH, we have double bond O as well. Okay, so for the double bond O, so for the double bond O, there are two examples. For the class of homologous series is either aldehyde or ketone. So the difference is that for the aldehyde attached to H, for the ketone does not attach to H. Okay, but then for the functional group, it is the same, carbonyl. So for the case of carbonyl, okay, we're only going to circle the C double bond O. So C double bond O, and then we're going to label it as carbonyl. Okay, so now let's proceed to example C. So again, for the functional group, be easier for us. Again, besides the carbon that present lah, besides the alkene. So here what we have, again, the same as previous one where we can see that we have OH. OH here, so I'm just going to circle OH. Again, OH, or the class is alcohol, but the name of the functional group is hydroxyl. Okay, and then we have N. We have N here, but then let us check, and there are few examples for functional group with N. So on page 7 here, we can see, again, N, we have C triple bond N by itself, or N that is attached to C double bond O. Okay, so when we look back on the example itself, it is N by itself. So if it's N by itself, the functional group is amino. This N is not attached to triple bond. It's not attached to C double bond O. So it is by itself. So it is amino. So we're just going to circle it. And then label it as amino. Okay. But then that is not the end of the functional group present. We can see that here we have hexagon. Okay. So where previously this hexagon, I'm not going to label it anything because this is actually hexane. So it is different because we don't have any double bond or triple bond here. Okay, but this case, we have double bond. We have 3 double bond. So it is different. So if the hexagon with the single bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond. Okay, so that's a functional group present. So we can see here on page 6, hexagon with a double bond, single bond, double bond, single bond is actually, we call it as benzene ring. So we're going to circle it and label it as benzene ring. Okay, so that's for example C. But then be careful, for benzene ring, it must be in hexagon, and then we have double bond, single bond, double bond, single bond, double bond, single bond. Alternating, ataupun dia kata gile-gile. Double bond, single bond, double bond, single bond. This one, all single bond. Okay, just check. This one I'm not going to label anything, just going to show to you. This is example of benzene ring, because it's the same kan? Double bond, single bond, double bond, single bond, double bond, single bond. But for this case, kan, this one is not benzene ring. Sebab, if this is a benzene ring, this one must have sini double bond, sini single bond, sini double bond, sini single bond, sini double bond. So this is actually, this one is benzene ring. This one is not. Okay, so what is the functional group? Then this one, you may try yourself. So please try yourself example D until G for page 8 and example H until J on page 9.